All right, let's get into it. Today, we're moving past all those Hello World AI demos. We're going to architect a real, production-ready AI chat app for 2025. This is the full blueprint. We're talking security, scale, and some serious intelligence. So you've probably seen a million tutorials, right? Hook up to an API, get a response back, bam, done. Seems easy. But here's the thing. The moment you try to take that cute little weekend project and turn it into a real-world application, the complexity just goes through the roof. Okay, so let's talk about what really happens when you go live. You hit a wall of real-world problems. Stuff like, how do you keep your app from getting hijacked? How do you give your AI a memory that actually, remembers things for more than 5 minutes? And what about integrating all those different tools without it turning into a total spaghetti code nightmare? Oh, and let's not forget getting stuck with one super expensive AI provider. These are the real challenges, and that's exactly what we're going to tackle today. All right, so to build something that can handle all that, you need a rock-solid foundation. And for the kind of AI apps we're talking about, that foundation, for me, is Deno. Let's dig into why it's pretty much tailor-made for this new wave of AI development. Okay, now this is where things get really interesting. Deno just completely flips the script on security. Think about traditional runtimes, like Node.js. Out of the box, they basically trust everything. Your code can hit the network, read files, access your environment variables, everything by default. Deno? It's the exact opposite. It's trust nothing. Your code can't do anything unless you explicitly say, hey, you're allowed to access the network. It's not a feature bolted on later. This sandboxing is built into its DNA. And listen, this isn't just some theoretical, nice-to-have thing. We see real-world vulnerabilities all the time. Permission bypasses, command injections, you name it. This is why that secure-by-default model is so absolutely critical, especially for an AI app. I mean, think about it. You're constantly feeding it untrusted input, not just from users, but from the AI model itself. Deno's entire architecture is built from the ground up to stop those kinds of attacks in their tracks. Okay, so our app is secure. Awesome. But now we've got to tackle the next huge problem, giving it a brain. Let's be real, LLMs by themselves have the memory of a goldfish. That context window fills up fast. So how do we fix it? We build an external knowledge layer, and the magic trick here is a technique called retrieval augmented generation. You've probably heard of it, RAG. So what is RAG really? It's actually a pretty simple idea. Before we ever send a question to the AI, we first do a quick search in our own private database to find any information that might be relevant. Then we take that info and basically stuff it into the prompt. It's like giving the AI a little cheat sheet with all the right answers right before the test. This gives it the exact context it needs to give a smart, accurate answer based on our data, not just its general knowledge. And here's how that whole pipeline works. Let's say you have a massive document, like a 5-hour video transcript. There's no way that's fitting into a context window. So, first thing we do is chop it up into smaller, bite-sized pieces. Then comes the cool part. We use a special model to turn each chunk into a string of numbers, an embedding. You can think of this embedding as a sort of numerical fingerprint that captures the chunk's meaning. We store all these fingerprints in a special vector database. Now when a user asks a question, we can search that database in a flash to find the exact chunks from that 5-hour video that are most relevant and feed those to the AI as context. Brilliant, right? Okay, we've got a secure foundation and a long-term memory. What's next? Well, our app needs hands. It needs the ability to actually do stuff in the real world. Send an email, check a calendar, query database. And this quote here from Andreessen Horowitz just nails the problem we're facing. APIs gave us a common language for software to talk to each other, but for AI models, there's nothing like that. Every single model, every service, has its own weird, unique way of defining and calling tools. It's a total Wild West out there, and it makes building agents that can talk to different systems a huge headache. So what's the solution? Well, one promising idea is the Model Context Protocol, or MCP. If you've ever used an IDE with autocomplete, you've benefited from something similar, the Language Server Protocol. MCP is trying to do the same thing for AI. It's an attempt to create a universal standard, a common language, so that any AI model can figure out how to use any tool as long as they both speak MCP. Right now, we're basically seeing two main schools of thought. On one side, you've got OpenAI's function calling. It's been around for a bit, it's mature, and it's very strict. You give the AI a very detailed instruction manual for a tool, and it follows it. It's super reliable for straightforward tasks. Then you have Anthropic's approach with MCP. It's newer and a lot more flexible. It's built for those messy, multi-step workflows where the AI might need to try a few things, see what works, and maybe even correct itself along the way. It's less like an instruction manual and more like a whole creative toolkit. So, a standard like MCP is great. It gives our AI its hands. But there's a catch, a hidden cost. The more tools you make available to the AI, the more you have to describe them. And every single word of that description gets stuffed into the model's precious context window. It's a huge new bottleneck that can cripple your app before you even start. Yeah, look at this number, 55,000. According to Anthropic, that's roughly how many tokens it takes to just define 58 common tools from places like GitHub or Slack. I mean, that is a huge chunk of your context window, completely gone before the user has even typed a single character. That's insane. So how do we get around this? Well, this is where we have to make a pretty big mental shift. The solution isn't to ask the model to call the tool. The solution is to ask the model to write code that calls the tools. We're basically promoting the AI from being a simple button pusher to being a little programmer, an orchestrator that writes its own scripts. So here's the play-by-play. The model generates a little snippet of code, let's say in TypeScript. We then take that code and run it. Now that little script can do all sorts of complex stuff. It can call multiple tools one after another. It can run loops. It can use if-else logic. It can chew through tons of data from those tools. But, and this is the magic part, it only passes the final, summarized, tiny little result back to the model. We've basically offloaded all the heavy computation, which keeps the context window squeaky clean and lets us build way more complex workflows. And boom, this is where it all comes full circle. I mean, think about it. Where are you going to safely run arbitrary code that was just written by an AI? You absolutely need a secure sandbox. And that is exactly what Deno's secure by default design gives us. It's the perfect isolated playground to run these little AI-generated scripts without ever having to worry about them breaking out and messing with the rest of your system. Okay, let's put all the pieces on the board. We've got the secure Deno foundation, the RAG-powered memory, the standardized hands, and the smart orchestration strategy. Now, let's see what the complete architecture actually looks like when it all comes together. Okay, let's follow the data. A user types something into the UI. That request hits our Deno backend. First stop, the memory. We hit our vector DB and maybe Deno's own KV store to pull relevant context using RAG. We package all that up with the user's question and fire it off to an AI gateway, something like OpenRouter. This is awesome because it means we're not locked into one model provider. Now, the model gets the request and thinks, I need to do something here. So it writes a little TypeScript script. And here's the key. That script runs inside a super secure Deno sandbox, totally walled off from everything else. The script does its thing, calls whatever tools it needs, and then sends just a small final summary back to the model. The model uses that summary to craft the perfect answer and sends it back to the user. It's this beautiful, secure, and seriously powerful loop. So, there you have it. That's the blueprint. Let's just run through the key ingredients one last time. You start with a secure runtime, which Deno gives you out of the box. You add long-term memory using RAG with tools like Deno KV and a vector DB. You stay flexible and provider agnostic with an AI gateway. You give it hands with standardized tools using a protocol like MCP. And the secret sauce is the efficient orchestration using programmatic tool calling inside a secure Deno sandbox. This whole setup is what takes you from a toy demo to a truly robust, intelligent AI app. You know, when you put all these pieces together, the security, the memory, the standardized actions, and this clever execution model, you realize this is about way more than just building a better chatbot. This pattern starts to solve some of the deepest, most fundamental challenges in building truly complex AI agents. Which really makes you wonder, are we looking at the blueprint for the next generation of AI?